This past podcast will be on chapter 13, which is all about transfer, problem solving, and critical thinking. So, we're going to talk about the different types of transfer, and what you're going to find is that there's quite a bit of overlap amongst these various types of transfer, and they're not necessarily exclusive from one another. We're also going to talk about factors affecting transfer. We'll get into problem solving, and more specifically, we'll kind of define what a problem is, the different steps involved with problem solving, and then different problem solving strategies. And we will also talk about how we can facilitate transfer, problem solving, and critical thinking. So first I want to show you this video. This is a guy who is a flight instructor, and he is going to talk you through transfer as it relates to learning how to fly a plane.
Now let's talk about transfer of learning. Now transfer of learning occurs when you learn something over here and it helps you to learn something over here. Now instructors should make certain that students understand that what is learned in one place can be applied to other situations, because it is instructor's job to help promote transfer of learning. So if learning a skill helps to learn another skill, learning skill A helps to learn skill B, for instance, then positive transfer occurs. If, on the other hand, you learn skill A and it hinders the learning of skill B, then negative transfer occurs. A good example of negative transfer: you learn to drive a car, you learn to steer a car with the wheel. You get into an airplane, you steer an airplane with the pedals, but you see people trying to steer an airplane with the wheel. That is negative transfer. The car actually hinders the learning, the experience in the car actually hinders the learning to taxi in an airplane. Now, let's assume that a student learns rectangular patterns. So they fly the airplane over a field, they learn rectangular patterns. And let's assume that that helps the student fly traffic patterns. Well, if learning rectangular patterns helps a student fly traffic patterns, what type of transfer would that be? That would be positive transfer. Now, what level of learning promotes transfer of learning? And the answer is the level of correlation, the highest level. That's the level where you can make associations, see relationships. Transfer of learning is not promoted at all at the rote level. You're not going to get transfer of learning at the rote level. Now let's talk about habit formation. Of course, the formation of correct habit patterns from the beginning of the learning process is essential to further learning. So you're going to learn habits, and then you're going to build on those habits. And the way you build on habits is you use the building block technique of instruction, and that ensures that you have proper habits and correct techniques during training. In other words, you have the student learn little tiny chunks. They learn to taxi, they learn to climb, they learn to descend, and they get good habits in all of those. Then they can fly a traffic pattern. So good habits on little sub-elements lets the student move on to combine them to a higher level, and so that good habits is very important to the building block method.
All right, so as you kind of saw in that video, transfer is really, really important to learning. So what we're going to kind of get into are the different ways that transfer can occur, and then, like I said, we'll review kind of how we can promote this. So transfer can be both positive as well as negative. Positive transfer means that when you're learning about something in one situation, it helps to facilitate your understanding or your performance in another situation. So even though reading and spelling are pretty different skills, knowing reading, or being able to decode words, can actually help you with the process of encoding words, which is spelling, right? So having all of those letter sounds and being able to blend all of those types of things also help you to pull apart those spelling or those sounds in order to form words. Negative transfer, on the other hand, is kind of the opposite of this. This is when you're learning in one situation actually makes it more difficult for you to learn or perform in a different situation. So, for me, the word epidemiology, I've used that term quite a bit now, and because of the way that that word is pronounced, sometimes I struggle to say epistemology. I have to kind of really think that through. So, another example of this might be learning tennis and then struggling to switch to a golf swing, right? Because they're so different. Um, in terms of vertical or lateral transfer, vertical transfer is when, you really need to have kind of some foundational skills before you can move on to learning additional skills. So an example of this might be a medical student who very clearly needs to understand anatomy and perfect their understanding of anatomy before they can move on to surgical techniques, right? Lateral transfer is when knowing a little about one particular topic can help you in another area, but it's not necessarily a prerequisite. So, knowing French, for example, isn't necessarily a prerequisite for understanding Spanish, but understanding French can kind of open the door to being more proficient with other Romance languages. In terms of near or far transfer, this really deals with the situation that the learner is learning in more than anything. So with near transfer, we have a situation that is very similar in both the superficial characteristics and the underlying relationships under which these skills will need to be applied. So again, kind of an example here. If you understand the formula for velocity, being able to apply that at a car dealership, a car factory, that relationship and the characteristics are going to be the same across these different environments. So in this situation, we're training people for near transfer, right? With far transfer, this is when the situation that you're maybe learning in is going to be helpful. So there's something about it that is similar to situations where you might need to use that skill, but there are some pretty different features. And so it's going to be more difficult for people to make that transfer of learning. So an example here, might be maybe the best example would be astronauts training for space, and they're learning all kinds of different conceptual pieces of knowledge in their initial training, and all of those things that they're learning, maybe velocity, right, to go along with that same example, is going to be helpful. But until they're actually in a situation where they have, zero gravity, that is going to be pretty different in terms of trying to apply that knowledge, right? Specific versus general transfer. So again here, this kind of deals with the tasks at hand. So with specific transfer, we're talking about teaching students using a task that is very, very similar to whatever task they're going to need to transfer their knowledge. So kind of an example here is if you're learning Spanish, it might really help you to understand Portuguese. General transfer is where the original task that students are taught in and the transfer task are actually fairly different. So one good, maybe relevant example for you guys would be that the study habits you learn for psychology and for really understanding psychological concepts might not be that helpful when you need to apply yourself or study for something like statistics, right? Or even research methods. You might find that you're a very successful student in your psychology classes, but when you have to learn research methods and statistical techniques, it's actually pretty difficult for you. And that's because it really takes a different approach to studying and learning. So in terms of the factors that can affect transfer, what we know is that the more meaningful the task is, or the more authentic it is, the more it's going to promote transfer of learning. And this is especially true if we compare this to like rote learning, where students are just kind of repeatedly exposed to material over and over. much less likely to transfer. We also know that the more thoroughly you learn something, the more easily you're going to be able to transfer that knowledge to a new situation, and that the more similar two situations are, the more likely the learner is to transfer that knowledge. Finally, learning about principles is going to be much more easy in terms of applying that knowledge or transferring it to new situations than learning about a bunch of different discrete facts. So if you're just memorizing bolded terms in your textbook, but you're not really understanding the overall theory, then you're likely not going to make use of that information in the same way. We also know that the more we can provide you with numerous and varied examples, as well as plenty of opportunities to practice, the more likely you're going to be to really be able to apply those skills. And that the longer the length of time is between the original task you learned and needing to apply that knowledge, the less likely you are to be able to transfer that knowledge. So another great example here, if you take the research methods class, but you wait a whole semester even to take the research methods lab, so in other words, you don't take them simultaneously, you're going to be much less likely to perform well in that lab because too much time has occurred between, learning that original knowledge and needing to transfer and apply that knowledge. And then finally, we know that transfer is influenced by the environment. So when environments encourage and expect transfer, or kind of that deeper level of knowledge, the more likely it is that learners are going to actually pick that up. So now we're going to get into problem solving. And problem solving, in terms of kind of starting with just understanding what a problem is, problem usually involves three components. So you have a goal, which is kind of the end state that you're hoping to get to, or what you hope the solution is going to accomplish. You have the givens, so these are all of the pieces of information that you have available to you when the problem is presented. And then you have operations, and operations are kind of those actions that you can potentially take to reach your goal or to address the goal. So when we engage in problem solving, usually we think about kind of a 4 or 5 step process. So typically we're first going to identify what the problem is, and usually it helps to collect some data to really try to understand what that problem looks like. Another way to look at this might be to look at the discrepancy between what is expected or hoped for and what's actually occurring now. So kind of almost doing a gap analysis to understand how far away from solving the problem we are. Problem analysis is where we maybe engage in almost kind of a problem solving session or brainstorming session where we go through all of the barriers that have maybe helped us to kind of keep the problem going, as well as potential solutions or resources we have that might help us to address the problem. Plan development would be kind of really looking through that list that we made of barriers that maybe we want to try to break down, or resources that we might want to build up and use more efficiently to start to address the problem. And so the questions we kind of ask here are, what is this plan going to address? How are we going to monitor for progress to know if we're getting closer to meeting our goal? Then we're going to actually implement the plan. And we want to be thinking about, also looking at integrity. So maybe we came up with a pretty good solution, but we didn't actually implement it the way that it was intended to. And so that is going to be an important part of the final step, which is evaluating how our plan worked. So was it actually effective? Did we implement our plan with integrity the way that we said we were going to, or the way we needed to? And if we didn't, why? So then we might even kind of go back to the beginning and start with a new problem solving process if our goal wasn't met. So some other problem solving strategies that were mentioned in your book, sometimes even talking yourself through a problem can be one way to start to tackle it, brainstorming, working backwards from the problem to kind of see how we got here. Using visual imagery can be helpful, drawing analogies, and then finally using external representations or even kind of like a 3D model of the problem can help you to better solve the problem. So how can we facilitate these things? Again, we want to help students learn things in kind of meaningful contexts, right? And we want to explicitly teach problem solving strategies. I think sometimes we make the assumption that people understand how to problem solve, and I think when we look at what happens in the real world, probably not that many people do. And so this is a skill we should maybe be teaching more often. Engaging people and learners in discovery activities, even through play, right, is a really important part of learning problem solving skills. So again, those meaningful, authentic contexts is really important. We know that students kind of need to have background knowledge or kind of a mental set in order to help assist with transfer. And that, sometimes those prereq skills should be practiced until they're automatic. So you wouldn't want a doctor to be performing surgery on you until they had practiced that surgery over and over and over on a dummy that they didn't, have any errors with, right? Now, that being said, practice doesn't necessarily make perfect, but it does increase the odds of successful transfer and kind of opening the person up for the cognitive capacity to engage in some problem solving. So we'll wrap up by talking about critical thinking. Critical thinking is really your ability to evaluate the accuracy, credibility, and worth of information in lines of reasoning. So it's reflective, it is logical, and it's based on evidence. And there are a few different ways that you can engage in critical thinking through either verbal reasoning, analyzing arguments, using kind of probabilistic reasoning, or engaging in hypothesis testing, which is one that a lot of scientists use. So that is it for today. You can hit the discussion board and write your post to reflect on today's podcast and what you read.